Welcome to the introductory lesson on loops. At the end of this video, we'll have command over Java's while and do while loops. I'm pretty excited about this because loops allow us to execute a block of Java code over and over again, as many times as we see fit. This is a pretty cool step in our learning process because the ability to perform small tasks many times in rapid succession is one of the things that makes computers better at certain tasks than humans are. To begin this video, let's create a new NetBeans project, enter the main method, and simply declare an integer and give it a value. You can choose any positive value. We're going to ask our program to print out the phrase "Hello World" a number of times equal to the value of our integer. To do this, we'll employ a while loop. While loop syntax looks a lot like we're writing an if statement. We begin with the reserved while keyword and follow it by two parentheses, inside which we're eventually going to place a conditional statement. Just like it was an if statement, the following block of code will only execute if our program reaches our while loop and evaluates its conditional statement to true. What separates while loops from if statements, however, is that when the end of the while loop's block of code is reached, our program will basically jump back and execute this line of code again, evaluating the conditional statement and re-entering the while loop's block of code if the conditional statement is still true. Let's start off by setting up the logic for our while loop. We have the number of times we would like our loop to execute stored in the value of integer I. But we're going to need a way to communicate this to our loop. Well, any loop that is not going to run infinite times is going to need to make some control flow changes within the content of the loop. In our case, let's change the state of our program each time the loop runs by decreasing the value of I, so that when I reaches 0, we will have ran the loop 5 times. If that's the case, that means that we only want our loop to execute when the value of I is greater than 0. Let's pause quickly and take a look at this line of code here. I equals I minus 1 is a perfectly valid statement. But there's a shortcut we can use that's a little faster and easier to read. We can use I minus minus to decrement the value of an integer variable by 1. Once we've set this up, the only thing left to do is place the functional code inside of our loop. That's simply a print line statement that says, "Hello World." Now, let's run our program and see what happens. There we go. 1, 2, 3, 4, 5 hello worlds printed to our window, just as we intended. Often, we allow small programs like the ones we're writing here to end when there's simply no more code for them to execute. However, while we're working with loops, we're probably going to make the mistake of accidentally creating an infinite loop and running a program that has no end. When this happens, we're going to need to turn our program off manually. In NetBeans, there's a handy little stop button right here. If we're running a program through a command prompt, Control-C is a common command to cancel the execution of a program. Now that we have a handle on basic while loop syntax, let's try something a little more complicated and much more dynamic. The program I have in mind is going to need some user input. So let's import java.util and set up a new scanner. Rather than gathering user input right away though, we're going to collect new user input every time our while loop successfully executes. Each time we gather this input, we're going to need somewhere to store it. So let's create a new string whose purpose will be to store the value of the newly acquired input. This variable's value will change a number of times throughout the execution of our program, because at the beginning of every while loop, we'll be assigning it a new value. Were we to simply execute this program, it wouldn't be very interesting for us, the user, because the old values of our input string would constantly be getting lost when we assigned it a new value. So let's create another string whose purpose is to store all of the concatenated values that we've gotten from the user. Then at the end of our program, we'll print out the value of this string so that the user can see we've been storing their input. To add the value of input to our all string on this line, there's a couple of things we can do. We can add strings with the addition operator just fine. So the statement all equals all plus input, with all and input being strings, and that being a plus sign, is perfectly valid. However, when we're adding something to itself and working with a primitive or a type that can act like a primitive, as string can, we can also use the plus equals operator, which performs the same function. We also cannot forget to re-implement our decrement of the integer value I so that our program doesn't run for infinity. Now, if we run this program and provide 5 strings of input, we'll see them all spit back out at us as expected, which is pretty cool, but I've got bigger plans for this program. Actually, if we'd only wanted to write the program we have right here, a for loop, which we'll learn later, might have been completely appropriate. But for what we're about to do, while and do while loops are pretty necessary. What I'd like to do is get rid of our counting variable in this program. Instead, we're going to allow the user to tell us when to stop executing our program. When the user sets the value of input to the string stop in all capital letters, then we'll quit executing our while loop and print out all of the strings they've given us so far. So we only want this while loop to run while the value of input is not the value stop. You'll notice that we're getting a precompiled error. And we'll get a full-on compiler error if we do attempt to run our program. That's because our program knows that when we attempt to execute this conditional statement for the first time, the value of input will not have been set. Even though the non-existent value of input is not equivalent to stop, it's very bad form. And in the case of a string here, not a primitive, not possible for our computer to access any of its methods before it's been given any value at all. One inelegant solution here would be to give input a start value, like we did with all. But there's actually a better way. Once our loop has executed for the first time, we know that input will have a proper value given by the user that may or may not be stop. So, what if instead of checking our conditional at the beginning of our loop, we checked it at the end? This is in fact an option. Do while loops operate just like while loops, but the first time they run, they won't check to see if a conditional is true. They'll simply run through and then at the end, check their conditional statement. We do need to put a semicolon at the end of the conditional statement on the back of the do while loop. I just mentioned that because I'm always forgetting it. Now, if we run our program, we can give any number of strings and then type in the string stop to see everything we've typed so far printed out to the screen. As a last little note, with just about anything followed by its own code block, you'll see syntax like this, where you have a keyword and maybe a conditional statement, and then brackets on the following lines. Or you might see the brackets start on the same line as the keyword and conditional statement. Both methods are completely valid. And in fact, this here with everything on the same line is probably quickly becoming more common. For the course of this video, I'm just going to spread things out onto as many lines as possible to keep everything easy to follow. Thanks for watching. I encourage you to play around with the program we've written here. Try executing loops that you think will push the boundaries of how much information a string can hold, or play around with loops that present an enormous amount of information to the screen. This is stuff that computers do that we simply couldn't with pencil and paper, so it's pretty neat. See you next time.